everyone, let's open the file PLECS. So welcome to this hands-on tutorial on PLECS. PLECS is a powerful tool for simulating power electronic circuits, bridging the gap between the theoretical concepts and practical applications. While there are many excellent tutorials available, including those from Plexim, which provides an in-depth coverage of various simulations, this session will also focus on PLECS simulations. Well, PLECS is available in two versions like PLECS Block Set and PLECS Standalone, and a broader explanation is provided by Plexim. Well, here we'll be using PLECS Standalone to introduce the basics of the software, demonstrating how to use it and connect block elements to design the circuits. Well, let's get started. To begin, we need to open a new PLECS model. As you guys have seen that I have opened the PLECS software, and then I need to create a model and rename it for easier identification. You can create a new model in one of the three ways while using the keypad control N, then this yellow page appears, or we can go to the file and tap on new model, and then this again appears. Additionally, there is the third way where a welcome screen appears, and over there we can simply tap on new model and we can open, and this again in page pops up. So before anything, we should save our file in order to prevent from any loss. Save as, we shall save it in downloads under the name simulations. Well, now that we have already saved the file, what we have to do next is to add the components. Adding components to a circuit can be in many ways, like browsing the library. Where's the library? Yeah, this is the library browser. First we have to browse the library. Over here, from here we can add the components, or we can open the library file from here by tapping Ctrl L after maximizing the circuit, and then it leads us to this very page. Then we can search the components here, like resistors, say, then these different type of resistors appears, and depending upon our requirement we can choose and add them. Let's get back to the original simulation model. So over here, what we have to do is that, over here, we have to add the components. So let's design a basic circuit. So I'll be showing you a basic circuit example. To verify, a simple circuit will connect a voltage source and a resistor to measure the current or power dissipated. This process highlights the ease of designing and simulating circuits in PLECS. So let's dive in and explore the capabilities of PLECS Standalone together. Well, let's type here resistor. We can either type in capital or in small letter. Now it's up to us whether we want it in vertical way or horizontal way. In order to rotate it, we simply choose, suppose this is the element, we have to move the cursor and tap on it, choosing the element and then tapping on Control R, and depending upon that we can rotate it. Well, R is done. Let's look out for voltage source. So there are different kind of voltage sources. We shall go with voltage source DC because we'll be simply providing a very simple plain value of voltage so that it becomes easier for us to understand at the very basics. So this is the voltage source, this is the resistor. We need an ammeter which will help us in measuring the current. So while connecting the ammeter, we have to be very particular with the direction of the current. So as we can see that the arrow is downside, so once we rotate, we have to be very careful while connecting, otherwise we'll be getting some negative value of the current. Now that we have already arranged the elements, we have to simply now connect. In order to move all the elements, what we can do is that we can either select all of them with the help of cursor, and using the keypad right, left, up, down, we can simply shift the positions. Now that we have shifted the positions, we again tap on the screen in order to deselect all the elements, and now we'll be simply connecting all of these elements. Once we have already selected all of these. We can do adjustments as per our need. If we don't want the names to appear, what we can do is that we can tap on it, click on right click or check on that, then go to format and deselect show name. Hence the name disappears. Similarly, we can do it same in case of resistor, in case of VDC as well. Now, in order to measure or know the value of the current, we need another display box which will show us the value, which will display us the value of the current flowing through the circuit. Now this is the display box. We can adjust it in any way. If we don't want the name, which becomes clumsier, we can just remove the name. And now what we can do is that we have to save it with Control S, and then we have to simulate. And now the thing is, the current here is 1 ampere because we didn't set any values for the resistor or the voltage. So let's randomly select 5 volts and the resistor to be 8 ohms. Excuse me. Now let's Control save and simulate. Now the value of the current is 0.6250, which shows that if excuse me, so since V equals to I upon since V equals to IR, so I would be V upon R, so I would be 5 upon 8, which gives us this value. Now if we have to see some graphical representation as well, so we can do that also by adding another element like scope. We type on the scope and then the scope appears. And now if we have to see or check the value of the graphical value of the current, we connect it, and every time we connect a new element, we have to Control save and Control T. Then once again double tap on the scope and it shows the value of the current going through the circuit. Now we can do some modifications and beautifications if we want to. Like suppose we want to measure the voltage as well, even though the voltage here is 5, we want to measure using voltmeter because we have to check on the scope, the graph. So we can do that by adding voltmeter, which is usually connected in parallel to the source, and then we connect it over here. Now we need a display. If we have to display the value of the voltage that is flowing, what we can do is that we can rotate this display so that it becomes easier. Now we can just drag it and place it close, making it look more aesthetic. Now we can also do one thing, just remove the name. So now once again Control save, Control T, here the 5, and now this is the R. What we can do is that we can also add here scope. Individually we can add scope. So once we add scope, we have to add here same drill of, if not interested in showing the display, you can just remove the display. So this is the voltage. Once again Control S, Control T. So this is the voltage supply, which is 5 volts, and then the current flowing over here is 0.625 amperes. Now what if we want to calculate P equals to IV? So we can, the Plex has also provisions to write over here. So let's type here. How would we make this appear? We have to double tap. So once we double tap, we write here, say P equals to IV. Now I do not know what's P. I know I from the circuit is 0.625 into 5 volts, and it would be giving us some values. We can also bold it by selecting and all and then clicking on bold, increasing the size, and then like this, dragging it here as per the requirement. Now to find the value of this P over here, what we can do is that we can bring a multiplication product element. So this is the product element. What we can do is that we can add the voltage and the current from here, and then once again a display box. Either keep tapping on the display and then bringing it, or we can do another thing is that copy pasting. Then this appears. Well, this was just to show, so I'll be deleting this file. Oh well, this is sorry. Yeah, I have deleted this file. Now once again, I don't need the names, so I find it much easier and clear while by removing the names, because it becomes haphazard. So control save, control T, voila. Now here we have the power. So what we can do is that we can double select it, just reduce the font size. If we wish, we can when drag this, place it over here. And if you don't want to, then we can remove it. These are just aesthetics which I'm trying to show you all. Well, this is the power. Now if I have to see the power graph, I can once again add scope, and then connect it over here with the same thing. Remove name, control S, control T. Control S and control T is the same drill we have to do every time in order to prevent from any loss, or if a file don't get saved, it will be a massacre. So I have gone through such phases, so I would recommend that every time we add an element or do any massive changes or any minor changes, we better control save and control T. Now double tap on this. Voila, here we have got the graph of power. Now let's say we don't want so many elements in the circuit and we have to make it look a bit more decent. What we can do is that, and also these might be complicating the path, because there will be too many wires if we are designing a very complex circuit. So what we can do is that let's delete all of these first. And now our motive is to, well, let me keep this. I have undone all of these, and I'll be I'll be keeping this at one corner. Meanwhile, I'll copy and paste a new, and I'll just show you the, a better version without all of these complications. What we can do is that over here I have made a duplicate of the original file. Well, this file, it simply appears once we double tap it. It should appear. So this actually helps in outlining the entire circuit for a clear perspective. So this is how it looks with all those wires. Let's remove these wires and scopes. So many scopes. Yeah.